Good morning, good afternoon, good evening. Welcome to Hands-on SAP Dev with me, DJ Q Macro, and welcome everybody. Visas in Bangkok, Thailand, and Helmut in Braunschweig in Germany. Good morning to you and welcome everybody. I can see we've got some viewers on, which is great. I feel, what's going on here? I feel as though, I have been a little bit sort of not in panic mode, but it's like all of a sudden it was 7:45. It's like, what? Quarter to 8, starting soon. I've not even set up. I've not even got my Elgato key light. I've not got the coffee made. I've made it now, thank goodness. I couldn't even find my Stream Deck. I need to plug it in to press the buttons to switch between the different scenes and everything. And relax. So it's a beautiful day. In fact, it's a beautiful day. Let me go to the main screen and what do I share? I took a picture this morning. Is it uploaded yet? Yeah, I took a picture. This was my morning. I had a coffee on the back deck, on the stern deck this morning, overlooking some fields, which is really nice. Behind me is the towpath, of course. That was a beer. So yeah, that's where I am, in near Windlehurst, High Lane. Anyway, that was the scene this morning. With my first coffee. I've got a second coffee. Maybe that'll make me a bit crazy. But anyway, I've got a link to the SAP developer news for you. Let me put that in there. That's I don't need that time code thing there. Let's get rid of that. Put that in the chat. Good morning, AP in Dusseldorf, and welcome. Helmut saying, calm down, calm down. Yes, exactly, calm down. Yes, I'm talking too fast. So, thank you, Helmut. We've got today the 5th and final episode in this little mini-series. I'm so glad you've come along on this little exploration, this little journey with me, because I hope it's been interesting, fun. I've really enjoyed digging into it with you and learning, relearning, revisiting, solidifying some knowledge that I might have had, I don't know. Andre, good morning to you from down under. Good evening. Good Friday. I hope you've got a nice drink there, whether it's coffee or some other beverage of choice. Welcome in. Thank you for joining. Yeah, so in fact, I was preparing. When I say preparing, what I do during the week is just like think about. Well, I watched the previous episode. Matthias, good morning. Good morning to you in Meschede in Sauerland in Germany. I sort of watched the previous episode thinking, what did we talk about last time? And obviously I had an idea of what I wanted to cover today with you, which is, let me go back to the intro for a second. What I wanted to cover today with you in this one, wrapping up. And the two things I wanted to talk about were point-free coding or tacit coding and composition. And I've sort of been, I had a rough idea of how I wanted to get to here. I mean, it's not as if point-free and composition is the culmination, the denouement, the pinnacle of what we've been trying to do here. But I do think that composition and point-free coding, in order to enjoy those concepts, probably grok those concepts, we also wanted to have already looked at things like partial application, currying, closures, and so on, because everything sort of fits together, hopefully in a way that makes sense, hopefully in a way that I've described okay to you. Aruna, good morning to you. Good morning and welcome. So anyway, I was thinking about how I was going to sort of land the point-free coding and function composition concepts, and I started writing a few things down, a few notes, and then I thought, you know what, I'll write a blog post. This was yesterday sort of mid-morning, and I sort of instantly regretted it. Those on, I think, obviously Helmut's on Mastodon, and I did post something along the lines of, I've started writing this blog post and I'm really regretting it now because I know it's going to take ages. But no, I
pushed on through. Let me go to the main top again. And here it is. So let me share that with you. I've just published it last night, late last night, and then I've just made a couple of corrections this morning. Let me put that in the chat. And generally, it goes through the sorts of things I want to go through today. We won't cover everything in here. You've got a bit of Haskell in there. Haskell, yes. So we'll do that. We'll go through there, if that's all right with you. And hopefully we'll understand a little bit more about what point-free coding is, feels like. And then based upon that, we can sort of, look at a little bit of function composition. And there's nothing really surprising or difficult. It's not as if we need to step up a level in terms of our brain. It's just more of the same in terms of, exploration. Anyway, that's what I want to do today. And let me go back to the main again. I already was at main. What I'll use is the products data set. This is from a developer challenge. The SAP developer advocates run developer challenges throughout the years, and this one I needed an OData service, and I do like Northwind, and so I created a little version of Northwind called North Breeze. Get it? North Breeze, small wind, Northwind, with just products and categories, I think. Yeah, products and categories, and maybe suppliers, I don't know. Suppliers as well, right? And it's a nice data set. We all know, well, hopefully we all know what the products look like. We've got 77 products, and they're categorized into different categories: produce, beverages, dairy, whatever, right? And it's got, things that we understand: unit prices, units in stock, whether it's discontinued or not, a little name, and so on. So we'll use that as the data. And this CAP-based Cat Node.js OData service is still running. I just left it there. So this OData service is from the developer challenge on APIs, I think. Last year, was it July, August, we ran that one? Anyway, and I haven't touched it. Anyway, so where I wanted to start, really, and there's I've downloaded the products JSON as well. Okay, so that is this. Okay, the products entity set. So, oh no, actually, yes. Okay, we'll do that. We'll have a look. First of all, we'll explore a little bit of point-free coding. In fact, let's go point-free Wikipedia. Tacit programming, there we go. Tacit programming, also called point freestyle, is a programming paradigm in which function definitions do not identify the arguments or points, the data on which they operate. Okay, blah, 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 blah. Interestingly enough, some of the examples are from Unix and JQ, which got me thinking, good morning, Dreadman from Poland. Welcome in. We're going to do some JQ examples because I like JQ anyway, right? So, point free is all about sort of expressing functions where you don't have to think about the data. So think of this in terms of, a nice high-level abstraction layer, high-level coding, solid-state building block-based coding. And this concept is not just a regular programming language concept. It's a concept that we can find in different places. Like, for example, JQ. I've got my little JQTE function, which will... Where's my head at the top? Okay, that's fine. This is a little bit like a JQ Explorer. There is also IJQ, Interactive JQ, which is a more mainstream. You've got JQ, of course, a more JQ products JSON. Do all that sort of scripting there. IJQ oh, I haven't even got it installed. Okay, well, IJQ is an interactive JQ. I've got a new PD. But this is my sort of interactive JQ in that I've got 3 tmux panes. In fact, dot files. If you want to see how it's defined, dot files scripts. Where is it? JQTE. There we go. This is what I'm running here. Okay, so that's what that is there. JQTE. Put that in there. Basically, the idea is that on the top right, I've got the source data. So that's the contents of products.json. On the bottom right, I've got, in fact, I've made that bigger. On the bottom right, I've got a little editor so I can write my filter multi-line, in my favorite editor, Vim, NeoVim. And on the left here, I've got basically, whenever I make a change in this in editor, it'll rerun the JQ script, whatever's contained in this file, on that data in the top right to produce the top left. So if I say, for example, dot value length 77, okay, fine. So if we wanted, for example, to find, in fact, let's have the first one first. You can see there, okay, the first one is not discontinued. If we wanted to find the discontinued products, for example, right, we could define a function. I mean, we could just also say, right, value map select discontinued, right, like that. And in fact, we can also say, well, how many are there? There are 8 discontinued, fine. But if we start thinking about this in sort of modular, in a modular approach, we could define a function, only discon. I can't spell discontinued. Continued, select discontinued. There we go, thank you. And then all we need to do is then say map only discontinued length. And then we can actually, what we'll say is, for example, product name. Just give us, expand that. The open square brackets, close square brackets is basically the iterator. Iterate over the things in the list, in the array, and then just, etc. Right? So that's a list of discontinued products. Now, if we also then wanted to say, well, give me some stock information, def stock info, let's just define something that will return an array, an object, where the key is the product name, for example, right? Yeah, that'll do. And then the value is units in stock, like that. That'll do, yeah, space there. What's bothering me is that my little finger is almost touching this Stream Deck, so I'm going to move it over there because it's just disturbing. Units in stock. Map stock info. Okay. Now, I mean, okay, we've got over here, it's a little bit sort of ugly. In that, we've got an array of objects where there's only one particular property in each object. So actually we can add those together and we, reshape that really nicely. Okay, but the key thing is that we're already thinking functionally. I mean, JQ is, a fully formed language and it has a very functional bent. It's a beautiful language. And as you can see here, these 2 lines, we're not defining the data, we're not even referencing, specifying the data that these 2 things are to operate on. The data in the dot value, the array, is just flowing through these pipelines. This is the pipe operator, right? In fact, we could even do that, right? Map only discontinued, and then pipe that into stock info. There. So you can think of this in terms of sort of high-level building blocks that you can I don't want to use the word compose here because compose has a special meaning, which we'll come to hopefully if I stop going on about this. But we're combining these into a pipeline here, right? We've got a pipeline, and then within this particular part of the pipeline, we've got another pipe. The data's flowing through, and it's just solid state. There's nothing going on there, right? Oh, ABAP Explained. Welcome, by the way. Incredible. I watched the whole Back to Basics CAP series. Didn't know there were more live series to come. Welcome in. Yes, Hands-on SAP Dev, we do different series, and we thought we'd do a little bit of an exploration of functional programming, partly because, a lot of the Node.js, CAP Node.js code is a beautiful sight to behold, and a lot of it, uses functional techniques. It's not like pure function programming, but to know a little bit of functional programming is never a bad thing anyway. To know another programming paradigm in general, it's always good to sort of think differently, right? Anyway, there's another thing, just given time, there's another thing about add. I'll just show you now. Let's map unit price. There, let's get the unit prices. Oh, actually, we will have the discontinued map unit price. So there's the unit prices, for example, but of the discontinued product. It doesn't really matter whether it's discontinued or not. However, if we wanted to get the average of those, we could pipe that into add first of all, right? But also then divide by length. There we go. In fact, I'll do it the way I've written it in the blog post, because then you'll be able to relate to it if you do read the blog post. I think what I did was get rid of that, and we'll just actually have just the first three. There. Yeah, okay, 15.6 recurring. I knew it was something to do with that. What is happening here, and this is a thing of beauty in JQ specifically, is that the data is coming through and being piped in, and it goes to, in fact, I'll show you what I mean. Where is it? Q macro L, there. Okay, the data goes in, and it gets sent both to add and to length, and then comes back again. Right? Anyway. That's that. Now, let's move away from there and just touch briefly on another context where this sort of point-free functional composition style also exists. Chiara, buongiorno, good morning. Hi, all network issues. Oh, okay, network issues. Hopefully your end, not my, well, not hopefully your end, but I mean, if there's any problems with my stream, let me know, please, always in the chat. Glad you made it, Chiara, and welcome. So we've just been playing around with some ideas in JQ, that sort of, discrete functions, high level building blocks, and now we're going to do the same sort of thing. If we just JQ.value, what should we do? Oh yes, there we go. We're going to do, we'll just expand those and have unit price and the product name, for example, right? Doesn't really matter what it is. Products.json. We get that. However, what we can do is we can say, pipe that into this formatter, this @tsv formatter. Let me make that bigger. Yeah, big is better. And we can have tab separated values. But what we also want to do is say raw output -- raw output, so it doesn't try to stringify, JSONify. By default, JSON will expect JSON. JQ will expect JSON, and by default, it will try and output JSON values. And of course, double quoted strings are JSON values, valid JSON values. But we want to say, just give us the raw output. Don't try and make them into JSON, and we get that. Okay, tab separated unit price. I think now, if we wanted, for example, to say, where's my head? Yeah, there were. To say, for example, sort numerically in reverse order. Okay. In fact, let's not do reverse order for now, so we can see the most expensive at the bottom there. 97 euros, pounds, whatever. Mishikobe Niku, 123 pounds, 79 Thüringer Bratwurst, and 263 pounds 50 pence Côte de Blay. Bly, I think. Some wine is the most expensive. And if we wanted to say, well, give us a top 3, we'll sort in reverse and say head -3. Okay, so we get the top 3 most expensive products. Now, look what's happened. Let's put what's been happening. We have also sent some data in a Unix pipeline context through the pipe into a sort function, as it were. We haven't specified with this part here. Let's go up to here. Let me highlight it. We haven't specified anything, right, in terms of data, because implicitly it comes through standard in and the output goes through standard out, and then the standard out goes into the standard in through the pipe to head -3, just to give us the top 3 records, right? We could even say, for example, top 3. Define it as a function, sort -nr head -3, right? And then we could say there, and then just pipe that into top 3, right? So we've composed a pipeline of point free of tacit function declarations. They're not really functions, obviously. They're just which sort. It's a executable. It's a binary, right? But the key thing is, we've just used these as building blocks, and I was going to say slam them together. We just put them together in a beautiful thing to build an even higher level building block, top 3. Okay, does that make sense? And of course, top 3, sequence 10. Oops, sequence 10. Top 3. We can use it anywhere now, can't we? Top 3. Crazy. Anyway, right. So that's enough sort of JQ and Bash, or Unix shell in general. Okay, Bash being the one true shell, obviously. Let's turn to JavaScript. So we've got our main from last time, and we've got the products JSON. Let's create I don't know, today episode 5. Let's create episode 5, right? I like to do it user bin env node. In fact, let's change mod plus x episode 5. What? X episode 5. Okay, so we've got episode 5. Episode 5 console.log hello. And what we'll do as well, now I'm on the right, my head's up here, so let me just see what we're going to do here. Yeah, let's just have another pane, and we'll just use our episode 5 and pipe it into entr, clear the screen and run it. Hello, there we go, fine. So we got our little, let me put the head at the bottom there, got our little sort of interactive live thing going on. Now, if we wanted to do a similar thing to what we've been doing so far, how about we first of all bring in const, we've done this before, right? Products equals require products.json.value. Okay, and then in fact const log, we had log, log equal console log, and then we can say log products there. Okay, we've got them. Okay, so far so good. Let me know if you're still following. I've got my phone up here, I've got my laptop down here. I think it's all good. Monitoring everything. Okay, so if we wanted, for example, to say, well, yeah, category, we've got this categories, we've got these different categories, and then 7, for example, category 7 is produce, and we've got, I'm picking 7 because there are only a few products. 1, 2, 3, 4, 5 products. Okay, Dreadman, thank you so much for confirming. So far so clear. That's good. So let's say we wanted to just output, I don't know, the, I don't know, the discontinued products, or the product, the products in this category. Okay, so let's just feel our way. Log. What are we going to do here? We're going to do. Should we do discontinued? No, let's just do this category thing. Category 7. So the simplest thing that could possibly work without using any sort of, you know, external Lambda, for example, thing for now, we could say products dot, let's put it on separate lines as well, dot filter, and we know now that filter is, you know, on the prototype of the array, and a filter takes a predicate function, as in a function that returns a Boolean, yes or no, true or false. So we could say, for example, x dot, there we go, category ID, right, equals 7. So now let's go across to here and see if that is correct. 1, 2, 3, 4, 5. There we go. Yeah, there's the start of the array. In fact, why don't we go here and say dot map map x x dot product name, right? Okay, we'll do that. So far so good, so far so clear, as Dreadman7 says. And that is quite a nice sort of starting point in terms of thinking about function chains. And in a way, it's sort of, you know, it's a nice way of thinking, jumping from the JQ example through the shell example, because the data is at the start, as it were, and it's sort of ready to go whoosh, 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 flow through this chain of functions. Okay, so that's not a bad thing. However, it's not amenable. It's not easy to. It's not amenable to modification. It's a little bit brittle. You know, it's not difficult to modify, but you've got to sort of go in there and, ooh, you know, you've got to change code. So one of the things we can do, actually, while we're here, yeah, well, this is sort of annoying me here. One of the things that we'll do is we'll import Lambda. In fact, what we'll do, yeah, we'll do it like I did in the blog post as well, I think. We'll start to use some Lambda functions, not because you can only do these things with Lambda, but in a way they represent the purest form, as in the cleanest form of the things we're trying to do. Okay, you know, yeah, okay. So we'll bring in, first of all, this prop function. Now, in a previous episode, I think I imported the entire in the entirety of Lambda and put it in R. So we had r.this, r.that. But just instead, we'll import individual functions using. Let me know what this is, what this construct is here with the open curly brackets and everything. We talked about this before on the live stream. We'll bring that, and then we can also say, for example, product name, like that. Same thing, okay? So it's, you know, it's not much of a difference. That, you know, that there to that there, that there to that there, that there, that, you know, in terms of length, it's, you know, it's the same length, same size, but to me, there are fewer moving parts. I mean, that's a ridiculously small example of that. However, if we bring in the curry function, and we looked at the curry function in a previous episode on this series, can somebody in the chat tell me what they remember the curry function does? look at the chat over here as well. You're okay? Yep, very good, very good, very good. Okay, so fine. If we now say, if we try to express something that we'll be able to use in this filter predicate position that's a little bit more high level. Destructuring, Dreadman. Dreadman is on it today. Thank you, Dreadman. Yes, exactly, destructuring. We could say, for example, a const. Every time I start a sentence, a line of code in JavaScript with const, I feel good because, you know, I know it's not going to change. Const. Only category, okay, is a function that takes a category ID, right? Let's say, and the ID, okay, we've got the categories here. Where are they? There we go. Category ID 7, for example. 7 is category ID 7, right? So the category ID is an integer. So we'll just call it n. And then it's given a thing, given an object x, because x is my favorite name for, you know, something, an object. We're going to define a function where we test whether the property, what's it called, category ID. Let me make that. There we go. There. Of x is the same as what we specified there, right? Does that make sense? There. So far, so good. So now, I'm just thinking, yeah, okay, we'll do that. However, what we want to do now, if we curry this, so nobody said on the chat what currying is. We've covered it in the previous episodes. To curry a function, or if a function is curried, it will work as follows. If a function's got 2 arguments that it's expecting, a curried version of that function will allow you to call it with fewer than 2 arguments, i.e., for example, 1 argument here. And what will be returned is another function that's just waiting for the next argument, x. So I'll say that again. Currying, a curried function, you can pass that curried function not all the arguments. So you can partially apply a curried function, partially applying as in only partially giving it a partial amount of the arguments. Partial amount is not English. So you can now say const build another building block with this. In fact, let's just curry that, of course. Curry. I mean, that's one small. I want it on 1 line. There we go. Is that still okay size-wise, font size-wise? Helmut, you're always good at telling me about the font size. Let me know, Helmut, if that's okay. So now we can say just produce. Right? So produce is this one here, right? Produce category. Right? Just produce equals only category 7. Okay. Now, let's just save that. Did I clear this? Yeah, I did do that. Clear the screen. Fine. Font size is fine. Thank you, Helmut. Thank you, Helmut. Good man. So now, if I, in fact, let me log out. Const just produce. Log just produce. So just produce is an anonymous function. Remember, we said that if we partially apply a curried function, we get a function back that's waiting for the final argument, right? So, for example, here, let's grab the first product, right? So, or just use it. Products log. Let's just log products 0, which is chai, and the category is 1. Okay, so if we say here log only category 7 and give it products 0, it'll be false, right? Fine. If we give it product 7, there, Uncle Bob's Organic Dried Pears. No, I'm not going to choose 7 because that's confusing with the product ID 7 and the category ID. I'm going to choose product ID 14, right? 14. Okay, 14 because this is 0 indexed in the array, so let's put product ID 13. Let's do that just so we can see, right? 13. True. Okay. So only category is being called in a normal way here in this line. However, just produce is the constant to which we have assigned the anonymous function that's produced when we partially apply only category brackets partially apply only category by just giving it a value for the first argument n. So now we can sort of imagine just produce. DJ, come on. There we go. So we've already started to make this the sort of the main meat of what this program's supposed to do. A little bit more high level, a little bit more declarative. Now, by building these building blocks, okay? So, what we can also do is start to think about adopting, what time is it? 30, okay, adopting the purer form of, as in the non-array prototype forms of map and filter, for example. Okay, so rather than specify the products here and then have the array prototype filter function called, instead, I'll leave that there for now. Instead, let's bring in filter, and let's bring in map as well. Okay, while we're here. No, actually, let's just bring in filter. So we can, we know what we're doing. And then we can say filter just produce okay, we get the same thing. Now, what have we done? This is sort of, an intermediate stage in the journey. And like I say in the blog post as well, it's making me a little bit not uncomfortable, but it's like, I'm not really sure I like that, because let's just join these two lines together. Yes, we've got this pipeline of data, but products there, it's sort of embedded there, and it's like, what's it doing there? What is it doing there? I don't like it. Okay. Plus, we've also got this. If I do that there, right? Let me just put that back down there again, and also comment that out. That's just going to produce an array. Okay. And then this array, on this array, we call the normal array prototype function map. So now let's go to the top and add map. And now start to think about how we want to do this. Map. In fact, let's just do that. Put that down there. Map that like that. Okay, we get the same results. However, what have we done now? We've now moved from a sort of a chain, a pipeline of functions, like we had before, products.filter.map, into something that's more like, in fact, Wikipedia composition programming. Function composition. That'll do. Function composition. I'm looking for something specific here. Where is it? Function composition. There. Okay. There we go. Let's make that big. Ooh. F composed with G. So it's a bit big now. If we have a look, basically, where is it? I want to see an example in here. I can't find it. Never mind. Ah, there we go. Look. We've gone from a sort of a pipeline to a composition. And a composition is basically where you have some data, X, and you call a function on it, and then you call a function on the result of that first call. So you apply G to X, and then you apply F to the result of applying G to X. And the way you write that, typically, and you'll see it in different places, is like that, with this little compose operator. And the beautiful thing is, in Haskell, you know, this amazing functional programming language, that's exactly how you express a composition. Okay, so we are sort of using, we're not expressing a pure composition. Well, I suppose we are, you know, in a way, but we're using a composition in that we've got this. Look at the brackets. Map open brackets something. So this is the function here. In fact, why don't we const name equals prop product name. Save that. Same thing. So now name is a function. So name is like the equivalent of, where was it? The F. What's the equivalent of the G? Well, the G, the equivalent of the G is the filter. Okay, and what's the equivalent of the X? It's the products. Okay, so how do we get from there, which is this literal composition, to something that we can build again as a building block, as a sort of higher level building block? 843, oh my goodness, high level building block. Well, we can bring in, first of all, Randas compose. Now you can build your own compose. In fact, I did a, yeah, there's something, yeah, you can easily create a compose function in pure JavaScript using using reverse and reduce or reduce right. But we haven't got time to go into that level of depth. I think I put it in the footnotes of the blog post. So now let's think, up here, this is the sort of the working bit, the thing that moves, and above this line is other things that don't move, solid state coding, which I don't know, our friend Andrew picked up on. So if we could say const produce info equals compose something, right? What is that something? Well, the way that if we look at the Randa compose, where's compose? That'll do that. Yeah. If we look at Randa compose, we can see performs right to left function composition. Okay, so right to left, and here it's sort of bottom to top because I'm in separate lines. Actually, let's do the right to left. Let's have that like that and say, for example, name filter just produce. Right? Is this going to work? So we've got produce info now as another function partially applied. In fact, even this is partially applied. We can now say, I think, produce info. Oh, no, produce info, compose, name, filter, just, yes. Okay, so produce info. Well, let's do it step by step first of all. Produce info, filter, just produce. What have I done wrong here? Let's do this then. Compose, name. Oh, of course. I know I've done wrong. And this and the reason. Let's just try that 1 second. Let's just do this. Produce info products. There we go. Now the reason I sort of slipped up is because I like to see them on separate lines, and it sort of like lines up, right? So what's happened there? What we've done is we've removed any semblance, any reference to the data, right? We've made it tacit, we've made it point free, okay? Because where's the products? The actual data, the array, in this definition. Nowhere to be seen, okay? So we've removed that. Because filter is a function that takes a predicate function, just produce, which we're supplying, but it also normally takes some data. But we're not supplying that. We're only partially applying filter, and we're only partially applying map because we're not supplying the data. Okay. And compose just composes these two things together. So compose is also still effectively, by the fact that actually compose is something that's like, where is it? Something that's basically this Z, right? This Z here is produce info. Z is still, implicitly partially applied. We could say the results and then apply it by like that. Products, the result. Same thing. Okay, let's get rid of that though. Just produce. Oh, the result there, right there. Okay. Now. Time's at 8:40. Oh, we're doing all right actually. Let me know in the comments if you're still with me. If everybody's left, let me just. Seems people are still there. That's good. What you could also do, and this is just playing around a little bit more with this idea of abstraction, high-level building blocks. This is there's a great talk by Brian Lonsdorf. I've referenced it in the blog post as well. And this talk touches on lots of different things, one of which is why the heck this whole thing is working anyway. Have you noticed that everywhere, in everything we've been doing, the data, where the data is specified either explicitly, when we did, for example, filter just produce products, right? Oops, yikes, episode 5 there, when we did that, the data is specified last. Notice when we define this only category function. Okay, lots of comments. Oh my goodness, all of a sudden, lots of comments. I'll read on this one instead. Helmut says, I really like the way you explain things. Helps me a lot to understand them better. Oh, thank you, Helmut. Thank you. Good. I want you to keep me honest here as well. If you don't understand things, if I'm explaining something badly, then let me know. Thank you. Dreadman, it looks very neat, although I can't imagine debugging it. Well, so maybe we should have a separate episode on debugging this sort of thing. I mean, part of the appeal to me is that it allows me to build the building blocks, test the building blocks, and then I'm using those as though they were sort of built-in functions, or maybe in the prelude or something, you know, Haskell term. So in a way, there's less to debug because there's a smaller surface area, but also there's less to debug because there are fewer moving parts. There are fewer things that are changing. You know, one of the things we haven't sort of talked about in this episode, but we have in previous episodes, is that immutability is a really important concept in terms of, you know, using it when applying functional programming paradigm approaches. So notice everything is defined as a constant. So things don't move. Things are not going to change. So I'm not saying you don't need to debug. Of course you need to debug. And there are certain techniques that you can use. You can sort of inject sort of taps into pipeline flows of data to throw out things, right? You know, to log out things, for example. So Dreadman7, you make a really good point. It's just we haven't got time to cover that in much detail, I'm afraid. So visas, yes, I am still here. Why is that? I can never see that heart's in the way at this point. A rerun is needed for me. Okay, fine. Cool. Where was I going? Oh, yes. So when we define this only category function, it wasn't just by chance, just by accident, that I specified the X parameter last, because I wanted to be able to partially apply it. And when we partially apply something, we're normally, you know, mentally and also in the program at the stage where we're still sort of building up the building blocks before we even get to thinking about applying the things to the data. So when we partially apply something, this 7 obviously is in the first position, the first argument. If we would have said like that, you know, obviously that's not going to work at all. Let me just get rid of. Oh, in fact, let me just get rid of that other thing there. Log there. If we would have said only categories, that's not going to work, right? We can't sort of say we want the data first, but because that is the thing that is the variable. That's the thing that's going to change when we iterate over the, you know, the list of things, for example. Let's put that back down here to say log, what was it? Produce info of products. Back to where we were. Okay. Oh yeah, one other thing before we leave, you could even, and this, I don't know whether I would say that this is more a style preference thing. Some people might say, oh yeah, you still sort of, you know, you still got things in here. So you could even say, for example, names, and then say map like that, and then just replace this whole line. You know, I mean, names is a bit of a stupid word. The names. The names. Same thing, right? And equally, you could just say just the. I'm not saying you need to make a change to the name. I'm just changing the name so we can see it's different. Just the produce products. And partially apply filter up here, like that. Finally, oh, that's right, yes, finally, I'm new to something else. So that's a composition, a function composition, and maybe also, you know, arguably in its sort of purest form, right? We've just got words, symbols, function names, no data to be seen, right? Going back to where we started in this episode, we had a look at, you know, pipelines, chains of functions where the data goes that way through them, rather than this sort of composition style thing which we saw here, right? There is in Ramda, like in other libraries like this, a function called pipe. I think it's called something else in a different. Anyway, Ramda calls it pipe, which sort of makes sense because, you know, we've played around with pipes in JQ and played around with pipes in Shell in this episode. Now, let's just define this as a produce info 2 pipe compose. Obviously, you won't call the names like this in real life, but there's the compose version. Pipe. Oh yeah, the names. In fact, what I'll do is I'll put them back on separate lines because that makes more sense to me, right? Just format that. Pipe, produce info pipe. Well, let's compose first, right? Pipe, just the name, products names. I'll get rid of that one there. There we go. And then have that there as well. Yeah. Come on there. So we've got produce info compose. We can do the pipe version instead. Pipe. Same thing. This time, the difference is the data flows through from the top there and to there, whereas this compose really reflects a sort of a more mathematical sort of way of thinking about compose. So there we go. Tatia, my best friend, can you prepare group Discord page your YouTube channel? I want to join. Not Discord, no. I mean, we've got the SAP community. We've also got, you know, the chat here and the comments here. You're welcome to, you know, put stuff wherever you want, but we're not running a Discord. Sorry. Not at the moment, anyway. We don't really have any plans to do that. So, Helmut, in some of my projects, I use functional Lodash, but I think Ramda is better. We'll use it in the future. I think good choice, Helmut. I love Ramda. I would definitely recommend you watch Brian's talk. It's called Underscore You're Doing It Wrong. And it's all about, well, the key tenet is that the way that, at least in, you know, maybe earlier versions of the underscore library, the argument order was the wrong way around. The data wasn't last, and therefore you couldn't properly program with it in a functional style, even though it said it was a functional programming library. That was the general tenet. Okay, better equals clearer equals yes, exactly. And actually, to use Helmut's sort of phrase at the bottom there, better equals, what did you say? Better equals clearer equals more functional. Hopefully, we've come to the end. Well, sorry, we have come to the end of the series and the end of this episode as well. And hopefully, you've seen and understood some of the core concepts and how they can be combined and how they are combined and how they work together. Because remember as well, you know, in here, for example, when we partially apply the only category, right, inside of the just the products and just the products function, there's a closure that's closed over the enclosing context. So we remember what the value of n is, which is 7, of course, right? So the closures are at play, partial application, currying, of course, higher order functions. All this stuff wouldn't work if JavaScript didn't support higher order functions values. So there we go. So have a great Friday. I'm not around next week because I'm doing a code jam in Den Bosch. So when we restart, we'll be doing something different. We're going back to CAP again, whether it's back to basics or I've got another idea on CAP. So watch this space. So we'll be restarting soon. So I wish you a happy Friday, happy weekend, and I'll see you soon. Bye for now.